In this video, we'll explore how to write the equation of a line when we know the slope and a single point. This form is known as the point-slope form of a linear equation. We're told that we know that the slope of a line is 1/5 and that the line passes through the point 3, 4. We're then asked to find an equation of the line in point-slope form and told to start with the slope formula, which has y2 minus y1 over the expression x2 minus x1 equal to m, using the given slope and 3, 4 for the point x1, y1. We also have a graph that shows the point 3, 4 on a line, but we're not able to see the y-intercept here. And this gets at why we need a second way of writing the equation of a line, using just the slope and one point. So let's start with this y2 minus y1 over x2 minus x1 equal to m. And we'll replace m with 1/5, as that's the slope of the line. And as instructed, we'll use the point 3, 4 for x1, y1. So I will replace y1 with 4. So I will replace y1 with 4 and x1 with 3. Now, in terms of x2 and y2, I don't know another point on that line. So if I look at this line, and I'll mark off more points on this line, I need another point that works for any of those. And so I'm going to denote it with variables x, y. So any other point on this line, they will vary, and I'm going to use x, y to denote them. So I will put y in for y2 and x in for x2. Now what I want to do is solve this for y. And to do so, I'm going to multiply each side of that equation by that denominator x minus 3. So on the left, I have that original expression, y minus 4 divided by the quantity x minus 3. I've multiplied that by x minus 3. And on the right, I have 1/5, and I've multiplied that by x minus 3. On the left side, this is going to give me y minus 4. And on the right side, I'm going to have 1/5 times that expression x minus 3 in parentheses. As a final step, I'm going to add 4 to each side so that I have this equation written just in terms of y. And that will give y equal to 1/5 times x minus 3 plus 4. This is the point-slope form of the equation. And our slope, as we will remember, was 1/5. And this line went through the point 3, 4, where 3 was x1 and 4 was y1. And I can see that my 3 and my 4 are still present here. So we're now going to generalize this. And in general, the equation of a line passing through the point x1, y1 with a slope of m is given by this. We have y equals m, and then we're going to have a parenthetical expression with x minus x1 inside it. And then after that parentheses ends, we're going to have a plus y1. And if we look at the example, we saw that we had y equal to the slope times the parentheses of x minus 3 and then plus 4. Here we've generalized it to any slope and any point x1, y1. And if we wanted to, we could go back to writing a slope from y minus y1 over x minus x1 equal to m and rederive this. And again, this is known as the point-slope form. As a final comment, I want to address that other resources will often use another version of this formula. It's very similar, except it doesn't have y isolated. So other resources often use y minus y1 equal to m times the quantity x minus x1 in parentheses. As you can see, the only difference is that in our version, we have y equals and then we've added y1 to each side. In this version, they've kept y minus y1 on the left, and you may see that in other resources. Our motivation for keeping it in this form is twofold. The first is that when we isolate y equals, we can easily put this into other forms of the line. The larger reason relates to topics studied later on in mathematics, in particular, something known as the vertex form of a parabola and something known as transformations. When we write the point-slope form with y equals m times the quantity x minus x1 plus y1, these later topics, which explore lines that aren't just straight lines, but are parabolas and other types of functions, these later concepts become direct extensions of this point-slope form. So it's that alignment with later topics is the main motivation why we simplify this to y equals m times the quantity x minus x1 plus y1.